All right, so you're looking, you have your NIEs, you know that you have a procedure that you maybe already read according to the Google Doc where you found all this information, but the process is simple for the first couple of reactions. What is the process? And I want you to write down like a one sentence, like what's your procedure, because I'm not, you guys will have these at your desk, but it'll be very quick, okay? So 1, 2, and 3, what are you doing for each of these? No, we've already done all that nonsense. We've done all the pre-lab. What is the actual procedure? What does it say in the paragraph before reactions? So you're mixing a 1 ml sample of each of these solutions where? In a test tube. So put down someplace 1 ml of each, 1 milliliter of each, in a test tube. That's for reactions 1, 2, and 3, because these are all going to be aqueous in nature as a solution provided to you. You will need to use a clean pipette. Don't just, I wouldn't use a graduate cylinder simply because it's just an extra step you don't need. So if you use a clean pipette, how do you get 1 milliliter in the pipette? You see the graduations on the pipettes, right? That's really, I'm just trying to get you to remember. Your pipettes they have like the bulb, and it says like 1 milliliter right here on some of them. Some of them are 3 milliliter bulbs, so the milliliter might be down here. So I would just pull up just about a milliliter in each pipette so you're not wasting time going to grad sills. Okay, so that's for step 1, 2, and 3. For part 4, it's a kind of a different step, but you have ammonium chloride and sodium hydroxide. Again, you're still using 1 milliliter samples, but where are you putting it? Into a beaker, not a test tube. So you are indicating the differences here. And then in terms of smelling the vapors, what are you supposed to do? Show me wafting. Wafting. Do not stick your nose over it. You will not like yourself after that, okay? On step 5, hold on. I've shortened this procedure. Which of these did I cut out? The iron one? On yours? Do you guys have all 3 of those? Okay, there's 4. I had another, the hydrogen one. On yours, tell me the 4th reaction on yours. Copper and silver nitrate? Hey, I didn't cut out, I cut out one of these. All right. You have ammonium chloride. I know you have. That's your number 3. Thank you. I was like, I don't think you had that one. So for your 1 and 2, my bad. Your 1 and 2 are going in test tubes. Your number 3 is going in the beaker, and then your number 4. Sorry, I've cut these down because you don't really need to see everything. You get the point after 1 or 2 reactions. Number 4, it's a slightly different procedure because you're taking a piece of solid metal, and then you're doing what? Small drop of the other solution. So it's just a piece of solid metal, and you'll use your pipette and you'll put 1 drop on it, and you'll look for a reaction. Okay? So it's a different procedure for every single reaction so far. And then number 5 for you guys, we're not going to use the thermometer yet, but for number 5 for you guys, you actually have some mossy zinc, and the mossy zinc is in a little tube in your station bucket, and you're going to get not all of it, not the whole, like there's a bunch in there. Do not take all of it. Just take a piece or maybe 2 pieces, very small pieces, and you're going to add them to 2 milliliters of your hydrochloric acid. And at that point, you'll see a reaction begin. What's on your reaction you predicted to form? What do you predict to form in this reaction? Zinc chloride and hydrogen what? Hydrogen gas, right? I need some space here. Okay, so essentially what you're going to do is in your test tube, you'll put your zinc and your HCl, and you're looking to see what's forming. What would be an observable thing here? Gas, right? So you're looking, you're like, oh, it's bubbling. How would one know what that gas is? Flaming splint test, right? So it's going to start bubbling. But what you need to do is capture this gas with something called a gas collecting tube. And that's just a test tube that's a little bit bigger than your normal size test tubes. Your normal ones are kind of skinny. There's one with a bigger mouth. It's not hugely different, but it is a little bigger, so it has like, it can almost like encapsulate the under one. Okay, so then you'll start collecting gas up here. And this is lighter than air, so it's going to float to the top of that big test tube. From there, someone else has the Bunsen burner going, sticks the stick in there, lights it on fire, Okay, and then we're going to remove this gas collecting tube from this test tube that's still reacting. This is probably going to sit in our test tube rack, and we'll remove the gas collecting tube and we'll hold it with hopefully hydrogen gas not escaping, but it's still there. We're going to hold the flaming splint here and we're going to listen. You got me? So we're reacting, we capture the gas. Someone else lights the flint, or the splint, flaming splint. And then we remove this from the reaction to the side, and we just hold the splint like in the mouth and listen. Are we okay? All right, I will demonstrate that when we get there because that's step 5. The first couple of steps will take you a little longer. Afterwards, clean, clean, clean. Filter any solids, no solids down the sink. That's always your rule of thumb. And then invert test tubes so that they can dry for the next class. I'll probably, tell you things out loud again. Are we okay? All right, please go to your labs. Closed-toed shoes and goggles. Do not start without me. You have to write these reactions down. You need to go back to homework from the past couple days.
Yeah, I was just doing it now.
Then jump in whenever you're done, okay?
91.
I'll tell you when we get back there, Corbin. I do not have the gas on yet, so don't even worry about the Bunsen burner until you finish the first 2 steps. I think I need to get you a couple more pipettes. That's the only thing you need from me. You need to read instructions very carefully. You do not contaminate my samples. Make sure your pipette is clean. I just passed out like 5 clean pipettes. Do not contaminate my samples or I'll haunt you in your dreams.
precipitate, you're probably not going to want to stir it up because you want to let it settle so you can see the significant differences in density. But once you see your reaction, you need to note it on your observation. You need to make sure everybody's on the same page. Don't run through this lab like speed. Just let everybody see the results and make it clean on what happens. Get everybody involved. If you have some people standing around the things ready, I'll kick them out of your group. Get involved in the reaction. Get involved in the reaction. Alright, if you've not touched the chemicals yet, get off your butt and touch the chemicals. Get involved with the lab. If you would clean out your pipettes in a beaker of water, that would make sure they're clean and don't accidentally dirty one. Closer and walk. Walk. Get in there. Walk to the Raise your hand if you can smell, if you walked in and you can smell. Alright, let's discuss real fast before we get too far. Does anybody have a guess or like a maybe a real life example of what that maybe smells like? No, bleach does not smell like that. It is a cleaning product. It's a Windex is usually has this in it. First is A. Ammonia, also known as, so ammonia is a cleaning product. Ammonia NH3 is what's found in Windex that makes it smell like this. And ammonia is what's in cat pee that makes cat pee smell like cat pee. There you go. Yes. Make sure you put that on. Hey, don't put Guys, the filter paper for filtering. Do not use the filter paper for this the copper. We just use Yeah, that's your black powder. It's actually silver bill. Alright, listen up for me. 3, 2, 1. Alright, so before we start step 5, I want everything tidy. That means all of the precipitate has been filtered, all the reagents maybe you've used go back into the buckets. Everything is prepared so that the step 5 can be done successfully without any loss or around without any distractions. Step 1, listen for this last set of instructions. Send one person with your copper and silver nitrate combo to me after rinse the silver nitrate off and replace the copper. So if you're not touching your hands, bring the whole paper towel or contraption with you and sit right in here. Bring it on. Send somebody now with your copper. I know you've all done that step. Read the instructions on the printed copy one more time before you start part 5. Read the instructions one more time. Okay, before you begin, listen up. 3, 2, 1. I'm going to show you over here what this is going to look like. So watch now. So Martin's group. So you have one test tube that's upright because this is the one that's going to have the zinc and the HCl in it. So what I'm recommending is you put the HCl in there first because it's the liquid, right? So you can just drop a piece of the zinc or 2 pieces of the zinc in. So it's not being held by your hand, it's sitting there and you're doing your thing. And then one person with the Bunsen burner is going to light and get this flint going. And then one person, I think this would be recommended to do with your test tube because, you know, just in case anything is hot, but it shouldn't. So you're just going to hold this like this and not press down, but just make sure there's a good seal. And you'll see gas starting to form up in there. And you won't think that there's a lot of gas, but there should be after maybe a minute. And then you're just going to hold it to the side, and the person with the test with the Bunsen burner is going to hold it here. Please don't put the gas over the Bunsen burner because the gas is flammable. No fireballs. Got it? So there needs to be, I know, sorry, safety. So this is going to just be pointing over here. The Bunsen burner, this is not going to the Bunsen burner. Cool? That's it. Keep your gas plugging sheet vertical. Keep the gas plugging sheet vertical at all times. That's not even a Turn it off. Turn it off. Thank you. Guys, I'm not doing this again. Figure it out. If you have a flamethrower, it is incorrectly set up. Don't try it again. It's the same mechanism because it's already wrong. Here's this. So maybe somebody else should set it up if the first person didn't do it right. I need similarity on the outside. Alright guys, listen up. I'm gonna provide an alternate procedure. Your bus inverter's on, it's fine, don't worry. I'm going to give you a little bit more concentrated HCl so this reaction happens in a reasonable amount of time. Because sometimes if you do a low concentration, I have provided you 0.1 molar. It's pretty dilute. It might take us too long to actually get bubbles started. So I'm going to give you some more concentrated HCl. So if you'll have a test tube upright for me, I'll give you some more HCl, and then you can begin the power test. Okay? 3 seconds and I'll stop striking. I fixed your bus inverter, stop striking. Alright. I think I gave everybody HCl. If I didn't, let me know. So guys, the gas is going to take a minute, let it go, and it should get a little bit in there just to give you the reaction. You maybe already saw it.
Oh my gosh, it's such a loud, hot program.
It is bubbling, guys. You just gotta let it go.
Oh my gosh.
Maybe plugging for a minute, you can try. I'm hoping there's no doubts. I might do a demonstration.
You're gonna go down here and you're staying on fire.
Assuming you're getting enough hydrogen. It's okay. Alright guys, listen, in 3. Listen, shush, I need you to be quiet. 2, 1, hold it over your mouth. Ready? Come clean. Ready?
Oh!
Alright, clean Turn off your gas and clean up. I'm going to do this one more time. Right, bring that. Alright, and we're going to do this again. 3, 2, 1. Come at me, bro. Come on. Alright, you're good. Okay, I'm going to keep collecting gas. You guys clean up. I need you back to the front in 3 minutes. 3 minutes. Yeah, sure, I don't want to.
Let's go, right?
Thank you. Fine.
Yeah. All right, 10. Let's go. 9. Everything should be cleaned up. Yes. Are you done? You guys think that? Okay. Labs in the box, please. Labs in the box. 8. Open back up your laptops. 7. Open back up your laptops. 8. Labs in the box. 5. Open back up your laptops. Go to my homework website. 4. Let's go, people in the back. 3. All of the lab sheets should be remaining at the lab stations. Please don't steal them. 2. Open back up your laptops. And labs are in the box. Go to my homework website, but click under tomorrow's homework. I'm just having you guys brainstorm now. Go to under homework for tomorrow. That's not you guys. All labs shouldn't be in the box now because everything else was already completed. So, you know. Actually, I did this under today. I did this under today. Yeah, it's under today. All right, click on the March Madness chemical reactions. SP's back to your table, sir. Let's go. So I'm going to briefly explain to you what you're going to be expected to do tomorrow. It should be a pretty fun day. We're going to be exploring chemical reactions in real life. So when you click on the March Madness chemical reactions, this document will pull up. And essentially, we are debating, based on your opinions, which is the best, the most important, the most imperative chemical reaction, either most important to you, most important to local folk or people, environment, or globally. Literally anything goes. There's no incorrect answer. But for this to go right, I need everyone to choose a different reaction to debate upon, because we can probably debate the same reaction against the same reaction. So we're going to take about 10 minutes right now to do our brainstorm phase, and then the rest is I want you to have a reaction in mind tomorrow, so that when you come in, I can say, okay, first come, first serve on what we want to do. So basically, your brainstorm, these are some questions that help you brainstorm. What's the most important chemical reaction in your life? Is it something happening around you or inside of you? Is it important locally, or is it on a global scale more important? And then why is it important? So, like, you know, try to come up with some ways, the reasons why you think this is so important. Who does it impact, or what does it impact? How would life be different without this reaction? Why do you feel it's more important than other reactions? So, like I said, there's not a correct answer. So just feel strongly about whatever you choose. Okay, and if it's something that's really cool or important to you, and you are going to feel so strongly about it, you're going to debate and convince anybody that it's the most important reaction. Tomorrow we'll make the product. The product is a poster, and the poster will include information basically based off your brainstorming phase. And then we will debate. We'll do 3 to 4 rounds of debates. And that debate will be team to team, and then we'll have to choose a winner, and then that'll be the first bracket, and then we'll move to the next part of the bracket, and so forth and so forth. Hence March Madness. So I'm going to let you choose a partner to work with, and you have 10 minutes right now to brainstorm. Go. You have to have a partner. You have to have a partner. Oh, let me get a piece of paper. Here. One at a time. Stand in line. Do not clump. Stand in the line.
line goes this way. It looks like it's the most logical. Now go brainstorm. Go get started.
Can I partner with computer?
Can you show me your mark? Guys, it's called research. You gotta do a little research. If you just choose chemical reactions, you'll never learn more.
I just want to see if people